So in this problem, it says radon is a colorless and odorless radioactive gas that can accumulate in homes. High levels of exposure can lead to health problems. Radon levels are measured in units of picocuries per liter. I'm guessing that's how to say that. The recommended radon level is less than 4 per liter. I'm just going to say 4, the recommended level. Okay, a housing development has 109 residential homes. So the entire housing development has 109 residential homes. So the finite population here is 109. Okay, let's keep going. The Homeowners Association would like to estimate the average radon levels in the development. Because it would be too expensive to measure every home, a sample of 30 homes was selected to be tested. So N is 30, and if we did 30 divided by 109, that is greater than 5%, so we do have to use the finite population correction factor here. Okay, and the average radon level was found to be 1.2 picocuries, or however you say that, per liter. So 1.2. Assume from the studies the population standard deviation is 0.5. We want to calculate a 90% confidence interval. So 90%, and this population standard deviation is known. So we are going to use that formula. Let me get that for us. Okay, so far we need, we have the first information we need for our confidence interval. We need Z, and we're doing a 90%. So if we're doing 90, that means there is 5 on each side. So we need to look up the probability of 0.95 to get our Z value. So we're just going to use Excel and 0.95, and we get 1.645 for Z. So Z is 1.645. So now we have Z. All right. Then we need our standard error for our mean. So here's the formula down here. So it's the standard deviation divided by the square root of n. So the standard deviation is 0.5 divided by the square root of 30. And we're going to round that to 4 decimal places. And we get 0.0913. Okay, so now we have that piece of information. We have an extra piece that we have to get because it is a finite population, and n divided by n was bigger than 5%. So we're going to do the square root of 109 minus 30 over 109 minus 1. Which is 160 divided by, 109 minus 30 would be 79 divided by 108. And we're going to take the square root of that and get 0.8552. So now we have the 4 pieces of information that we need to work this. Okay, so if you look at our formula over here for the upper and for the lower, X bar is 1.2, which is the sample mean. I'm going to move this up a little bit. So 1.2 plus and 1.2 minus Z, which is 1.645, and then the standard error of the mean we calculated as 0.0913, and then the population correction factor. And let's see what we get. And you will get 1.07 to 1.33. Does it appear the average is below the recommendation? Well, the recommended level is less than 4. So yes, because all the values in the confidence interval are less than 4 picocuries, or however you say that, per liter.